Hello GATE aspirants. Welcome to part 13 of GATE Classical Mechanics series. Question number 41. A particle of mass 1 kg is released from a height of 1 meter above the ground. When it reaches the ground, what is the value of Hamilton's action for this motion in joule second? G is the acceleration due to gravity. Take gravitational potential energy to be 0 on the ground. So on the ground it is 0, and suppose it is dropped from some height, and at t is equal to 0, particle is here, and let's consider this is some arbitrary position, and it is at some distance z above the ground, and it is okay, the height is 1 meter. This is given to us already, so this distance is 1 meter. That means this portion will be 1 minus z, and when this is completed, this time will be time of flight. So first of all, we need Lagrange's equation. Lagrange's equation, Lagrangian for this, which is half m z dot square, that will be kinetic energy, minus potential energy, which is mgz. This is 0, so above it will be positive. Now it is dropped from rest, that means it is released. So u is equal to 0. That means z dot will be v is equal to u plus at. So g 0 plus gt, and distance covered is this 1 by z is the distance covered. So s is equal to ut plus half a t square. So these are the equations. So from here we can write z is equal to 1 minus half into gt square. So we have z dot and z with us. So this is a Lagrangian, we can substitute it here, and we need time interval. So initially it is 0 and this is capital T. So at z is equal to 0, the time taken will be capital T. So let's substitute in this equation. You will get 0 1 minus half g t square. So from here t is equal to under root 2 by g. Now this integral will be s is equal to, integral is from 0 to t and L dt, which is equal to 0 to under root 2 by g, and L is, this is L, so half m, and z dot is gt, so that is g square t square minus mg into this z thing, which is 1 minus half gt square, and this whole thing into dt. So s is equal to integration 0 to under root 2 by g, then we have half m g square t square minus mg plus half g t square into mg, so m g square t square into dt, which is equal to, s is equal to half root 2 by g. Half plus half is mg square t square minus mg, and then we have dt here. So integration will be mg square t cube by 3 minus mgt, and limits are 0 to root 2g by 3. So s is equal to mg square by 3, t cube is root 2 by g raised to 3, which is 2 by g root 2 by g, minus mg root 2 by g. Now if we take this mg and root 2 by g common, then this plus this g and g will cancel, and we have mg here, and this is 2 by 3 minus 1. So this is 2 by 3 minus 1 into, we have this mg under root 2 by g. 2 by 3 minus 1 is minus 1 by 3, and this is g, so this will be m into root 2g, and mass is 1 kg, so m will be 1, so this is minus 1 by 3 into 2 root g. So answer is option D, minus 1 by 3 under root 2g. Next question. If x dot and y dot plus alpha xy is a constant of motion of a two-dimensional isotropic harmonic oscillator with this Lagrangian, then alpha is. This is the Lagrangian and we want to find out alpha. So first of all, let us find out the corresponding equation of motion, which is d by dt dou L by dou x dot minus dou L by dou x is equal to 0. And dou L by dou x dot will be m x dot. So this will be m x double dot minus, this is half kx square. So this will be kx and minus will become plus. So kx is equal to 0. That means x double dot plus k by m x is equal to 0. And we can write it as omega square. So from here x double dot is equal to minus k by m into x. Similarly, d by dt of dou L by dou y dot minus dou L by dou y is equal to 0. So m y double dot plus ky is equal to 0. So this plus k by m y is equal to 0. So y dot is equal to minus k by m y. Now here it is given that x dot y dot plus alpha xy is some constant. So its derivative will be 0. So let's take derivative. So x double dot y dot plus x dot y double dot plus alpha x dot y plus alpha x y dot. This is equal to 0 and we have these values which we can substitute here. So this will be equal to minus k by m into x y dot minus k by m into this x dot y, then plus alpha x dot y plus alpha x y dot, and that is equal to 0. So this is minus k by m x y dot plus x dot y plus alpha into x dot y plus x y dot, that is equal to 0. So x dot y plus x y dot in bracket minus k by m plus alpha is equal to 0. That means alpha is equal to alpha minus k by m is equal to 0. So alpha is equal to k by m. So here option A is correct. Alpha is k by m. Next question. A particle of unit mass moves in a potential V of r is equal to minus v naught e raised to minus r square. If the angular momentum of the particle is L is equal to 0.5 root v naught, then which of the following statements are true? So we need to find out equilibrium points here. Now V effective is equal to L square upon twice mr square minus V. L is 0.5 root v naught, so this is 0.25 v naught upon 2m. Mass is unit mass, so m is 1. So 2r square minus v naught, minus it will become plus, so plus v naught e raised to minus r square. This is plus, sorry, plus v, and this is minus. So this is 1 by 4, 1 by 2, so v naught upon 8r square minus v naught upon e raised to r square. So this is the potential. Now this will, if we plot it, then this will look like this. First part is r square, so it is 1 upon r square, so it will look like this. So this is v naught upon 8r square part. This is minus v naught, so here suppose we have minus v naught when r is 0, and as r increases, this will increase like this. So this is minus v naught e raised to minus r square. So if we add these two, then what we'll get is something like this. It will be of this part. So we need to find out equilibrium points. So this has two equilibrium points, one is here and one is here. One is stable and one is unstable equilibrium point. So there are two equilibrium points along the radial coordinate. So option A is correct. There is one stable equilibrium point at R1 and one unstable equilibrium point at R2 greater than R1. So B is correct. This one is unstable, this one is stable. So option A and B are correct for this. Next question. A system with time independent Hamiltonian H has two constants of motion F and G. Then which of the following Poisson's bracket are always 0? Now if H is the Hamiltonian and F and G are constants of motion, then Poisson's bracket of HQ is 0 and HP is 0. Now first option, we have HF plus G, which is equal to HF plus HG, and both are 0, so this will be 0. Then option B, we have HFG here, like this. Now here we will use one identity, that is if we have HFG, then plus FGH plus G, and then the other part, that is HF, in a certain cyclic order, then this is equal to 0. So from here HFG is equal to minus of FGH minus GHF. So this will be minus of F, and this GH is 0, so this is F0 minus this is G0, so this will be 0. So for option B it is 0. Now option C, we have H plus F and here G. So this is HG and plus FG. Now HG is 0, but FG is not equal to 0. So this is FG. So we don't know if it will be 0 or not. And for option D, we have H and here H plus FG. So this is HH and plus HFG. Now this first part is 0, and for the second part, separate it out. So this is HF, then G plus F, and then HG. HF is 0, HG is 0, so this is equal to 0. So for option A it is 0, so for which it are always 0, so A, then we have B and D. So here option A, B and D are correct. Next question. In the action angle variables I1, I2, theta1, theta2, consider the Hamiltonian H is equal to 4 I1, I2 and theta1, theta2 in between 0 and 2 pi. Let I1 by I2 is 1 by 2. Which of the following are possible plots of the trajectories with initial conditions in theta1, theta2 plane? Here it is given that H is equal to 4 I1, I2. Now theta1 dot is equal to dou H by dou I1, which is equal to 4 I2. Similarly, theta2 dot is equal to dou H by dou I2, which is equal to 4 I1. So d theta1 by dt upon d theta2 by dt, which is equal to d theta1 by d theta2, is equal to 4 I2 upon 4 I1. So 4 will cancel and I2 by I1 is 2. So if we plot a graph of, here we have theta2 versus theta1. So if we plot graph of theta2 versus d theta1, then it is 1 by 2. So the slope of theta2 versus theta1 graph, it should be half. So it should be half, slope should be half. Here slope is 1 by 4. Here we have this is 1 by 2. So yeah, this option is correct. Here we have 2 by 4. So this is also 1 by 2. Here we have 2 by 1. So this is wrong. So option B and C are correct. Next question. Two identical particles of rest mass m0 approach each other with equal and opposite velocity v is equal to 0.5 c, where c is the speed of light. The total energy of one particle as measured in the rest frame of the other is E is equal to alpha m0 c square. The value of alpha is, we have one particle m0 whose rest mass is m0 and they are moving towards each other with this velocity. Now what will be relative velocity? This is equal to v1 minus v2 upon 1 minus v1 v2 by c square. So velocity 1 is 0.5 c minus second velocity, this is in opposite direction, so minus 0.5 c upon 1 minus 0.5 c into minus 0.5 c upon c square. So this is 0.5 plus 0.5, so 1 minus 0.5 into 0.5, 0.25, and this is plus. So c upon 1.25, which is 5 here and 4c. So 4c by 5. Now E is equal to mc square, which is m0 c square upon 1 minus v square by c square. That is m0 c square upon 1 minus, from here v by c is equal to 4 by 5. So v square by c square is 16 by 25, which is 1 minus 16 by 25 is 9 by 25, which is 3 by 5. m0 c square, that is 5 by 3 m0 c square, and 5 by 3 we have to calculate. So alpha is equal to 5 by 3, which is 1.67. So answer is 1.67. Answer given in the answer key is 1.65 to 1.70. So these were all the questions from classical mechanics part from GATE 2022 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.